Every time it rains, your city silently flushes millions of invisible toxins into its rivers and oceans, not because we lack the will to stop it, but because no engineer has cracked the fundamental deadlock that makes it possible. Hi, we are Arjun, Garg, and Mohan Parthasarathy from Thomas Jefferson High School for Science and Technology. We built Vascura HydroNet to finally break that deadlock.
We bring biological reverse engineering and advanced fluid modeling to the table, tackling a critical unsolved problem the U.S. Department of Energy identifies in urban water infrastructure.
15 microplastic particles fall per square meter of our cities every single day. Urban stormwater completely bypasses treatment plants, flowing entirely unfiltered into our ecosystems. 94% of urban tap water contains microplastics. Over 2 million marine animals die from this pollution annually.
Municipalities want to act, but are paralyzed by a fundamental engineering deadlock. Fine filters catch microplastics but clog instantly, causing street flooding. Coarse screens prevent flooding, but microplastics pass right through. For decades, city planners have been forced to choose one or the other.
The current landscape reflects this failure. Fabric drain guards flood streets. Hydrodynamic separators cost $10,000 and more and require full street excavation. Static screens offer zero microplastic capture. Not one solution provides predictive data or waste-to-value potential.
To break this deadlock, we looked to biology.
Pine trees solved this exact fluid problem 300 million years ago, using a microscopic valve in their xylem called the Torus-Margo pit membrane, which flows freely but dynamically seals dangerous gaps. We reverse engineered this biological safety valve into a scalable physical stormwater filter.
Vascura HydroNet is a compact, modular filtration system deployed at stormwater outfalls. A radial fin intake laminarizes turbulent water, and a graded cartridge distributes load across filtration layers, eliminating the clogging versus flooding trade-off entirely.
Every unit is powered by a physics-informed digital twin. Our proprietary mathematical model simulates contaminant flow across an entire urban network in real time, predicting pollution concentrations, optimizing installations, and triggering maintenance alerts before the failures occur.
Once filters are saturated, we transform the captured waste into high-value biochar and graphene. These materials are sold into the green construction and water purification industries, with 50% of the profits returned to cities as a direct financial incentive.
Hardware costs per unit are $44.50 against a $150 sales price at a 70% gross margin. Our digital twin subscription costs $5 per node to run and charges $50 at a 90% gross margin. Cities pay willingly because it replaces thousands in blind manual inspections.
The global stormwater market is $20 billion. Our beachhead is MS4 regulated municipalities facing immediate EPA fines, a $200 million serviceable opportunity. Private contractors priced out of $10,000 separators, and global smart city developers are our two next tiers.
Our ERRC grid allows us to eliminate street excavation, reduce blind inspections, raise filtration to sub-50 micrometer capture, and create a compliance as a service model with waste-to-value revenue, a market space that simply did not exist before.
No competitor checks every box. HydroNet is the only solution achieving microplastic capture, clog resistance, flood safety, easy installation, predictive data, and circular economy value, all simultaneously.
Our to-be strategy canvas shows it clearly. Competitors zigzag across trade-offs, while HydroNet holds high across every dimension at a fraction of hydrodynamic separator costs. That is value innovation.
4 reinforcing revenue streams: hardware sales, consumable cartridge replacements, SaaS dashboard subscriptions for automated EPA reporting, and secondary market resource recovery. Every stream locks in the next.
We anticipate break-even by year 3 at $1.8 million revenue. In addition, we anticipate $127.5 million revenue with $82.5 million earnings by year 10. And most importantly, that same year, our network captures 1.4 kilotons of microplastics. Financial upside and environmentally impact are perfectly aligned.
We are not just pitching a concept, we are pitching validated engineering. Real CAD, real CFD simulations in MATLAB, and real physical prototypes tested in our lab. Our experiments quantified mass capture and physically proved our graded bio-inspired architecture outperformed static meshes, exactly as our models predicted.
Fairfax County's Department of Public Works validated our operational model. Members of Virginia's House of Delegates endorsed our environmental impact, and MathWorks officials supported our computational development. Real institutions are endorsing our results.
HydroNet advances UN SDGs 6, 11, and 12. As the EPA enforces new regulations on tire-wear particles like 6-ppd-quinone, cities need compliance tools urgently. We deliver real-time data, cut maintenance costs, and prevent microplastics from destroying our watersheds at scale. Vascura HydroNet is not just a filter. It is an intelligent immune system for the smart city of tomorrow.